Hey guys, today we're going to be doing this lab for AP Physics. So, it's the introduction to set up an experiment to determine the coefficient of static friction between a long flat wood board and a small wood block using the equipment provided. Okay, so the first thing before I read the instructions is I'm going to set up this experiment. So, to determine my coefficient of static friction between a long flat wood board and a small wood block. So I know that to determine this, I'm going to need an inclined surface. And here is that small wood block they were talking about. Here it is. And now I have to describe an experiment for determining the coefficient of static friction between the wood board and the wood block. Assume the equipment is found in your school physics lab. So, draw an experimental setup of the board and the block, indicate each quantity, describe the overall procedure, and okay. So, I have to determine the coefficient of static friction, and the first way we approach this is I break this up into its forces. So, let me just move this over here. Okay. So, I have my block, and I'm gonna label all the forces. I know that I have force gravity right here, right? Because it's always in the center, right? Let me just put it like this. I'm gonna show you all the forces that I have before I label them. We have the normal force opposing, force normal. And then we have force of static friction opposing the direction of applied force, and then have this. Okay. So, I'm trying to determine the static, this is what I'm looking for, which is equal to force static over force normal. And in order to determine force static over force normal, here's my force normal, here's my force static. I'm going to have to break the force gravity into components to solve for the total force net, which I can plug in. So, we start by breaking this into FG perpendicular, and then this is the FG parallel, right? Okay. Now the first thing, let's say I'm solving for, is force static. Force static is right here. Force static, we're going to be using the FG parallel. So, we have FG parallel. Sum of FG parallel is going to be equal to force static friction, because we're in Newton's first law here. It's not moving yet. It hasn't moved yet. It's about to move, but it hasn't. So you're in where F net equals 0. So basically this was like FG parallel minus Fs equals 0, and you just add it to the other side. Okay. So this is true. And for FG parallel, we know that there's like a set equation. There's a set way to find FG parallel, which is mg sine theta. This is how you find FG parallel. Okay, now that you've found force static friction right here, you need to solve now for force normal. In order to solve for force normal, you have to take a look at what force normal is. Force normal is a vertical component of a force, which means we're going to have to use FG perpendicular with all the other the vertical forces, but you see that there's only one. Okay, so the sum of force gravity perpendicular is going to be equal to my force normal minus my force gravity, because remember, gravity is pushing down right here, and gravity is down, and force normal is up. So you're subtracting to find the sum, equals to ma. This is a is equal to 0, so it's telling you basically that force normal is equal to force gravity, because this is 0, so you can just add force gravity to this side. And we know that if Fn is equal to Fg, and this is equal to Fg perpendicular, we know that there's also a set formula for that, meaning Fg perpendicular is equal to mg cosine theta, which is also equal to force normal. This is your second part. So, to write the formula, the formula is mu is equal to force static friction over the normal force. And we just found our force static friction, which is mg sine theta. And then we just found our force normal, which is mg cosine theta. You can make it a hypothesis that these are going to cancel out, leaving it as sine over cos theta, which is going to equal tan of theta. So mu s is equal to tangent theta. And this is your answer for deriving an equation, part A. Okay. Next, a physics class consisting of 6 lab groups want to test the hypothesis that the coefficient of static friction between the board and the block equals the coefficient of the kinetic friction. Each of the group determines the coefficients, and the group's results are shown below. So they're saying the averages are equal, right? And they want to determine if they're equal. They want to test it. So we have to take a look at every single attempt. So in the first lab, the coefficient of kinetic friction is less than the coefficient of static friction. Second lab, the coefficient of kinetic friction is again less than the coefficient of static, and then you see that repeats here. Then it does not, actually the coefficient of kinetic friction is greater, and then again returns. So it asks, based on this data, what conclusion should the students make about the hypotheses about the coefficients being equal? Well, we can obviously say that they're not equal, because you can observe that in lab number 5, the coefficient of kinetic friction was greater than static friction when we observed that 1 through 4 and 6, we observed that the coefficient of kinetic friction was actually less than the coefficient of static friction, as it should be. Start reading first. Okay. Next problem says, a metal disc is glued to the top of a wood block. Okay, so a metal disc is glued to the top of this wood block, right? Metal disc. And it's the mass twice times this, so this is 2x wood. Does the coefficient of static friction between the bottom of the block and the board increase, decrease, or remain the same? So the answer is that they remain the same. The reason you can justify this is, 1, you found your formula for coefficient of static friction. Tangent theta equals coefficient of the coefficient of static friction is not affected by mass, because the formula is not affected by mass. Whether it's 20 kilograms, whether it's 10 kilograms, it's a constant, and this tangent theta has nothing that indicates that it'll be affected by mass.